Yeah. Okay. So let's start now. And you know, in the multiple linear regression or whatever regression we had learned so far, there your y was continuous. You're applying the y when it was continuous. Now we'll be working when your y is discrete or categorical. Yeah. So deciding the classification algorithm will always be depending upon what y we have. And if your y, the y means what? Y means I'm talking about the output variable. If your output variable is categorical, then we'll be talking about the classification. Okay. So let me share my PPT. I hope my screen is visible to you all.
Yes, sir.
Yeah. So here, let's talk about this logistic regression. And obviously, just like the linear regression, we will have this logistic regression, and it is of two types. One is simple, another is multiple. So when it comes to simple or multiple, here it will be decided on the basis of the number of variable, number of the input features. So for example, you see here that in this case, when you will have single input variable and your y is discrete, then you are going to apply simple logistic regression. And when you will have multiple variables and your y is discrete, then you'll be applying multiple logistic regression. Next. So basically, when it comes to this logistic regression, although it performs classification, but actually it belongs to regression family. Why? Because you know that what is the equation of a straight line? It is minus infinity to infinity. Yeah. Okay. And what we do, basically, somewhere we apply some transformation technique. Somewhere we apply this probabilistic equation, that is logic function, and that logic function just convert it into 0 to 1. And then what we do, when the value will be in the form of 0 to 1, then we just try to find out some threshold value. And if any value will be less than or equals to that threshold value, it will become 0. And if any value which is more than this threshold value, then it will become 1. And then you can see that the entire data will become either 0 or 1. So in this way, your minus infinity to infinity gets converted into 0 or 1, which is your desired outcome. Yeah, you can consider in another way. Try to understand. Suppose you have this straight line. Okay. Now, let me use this paint. Okay. Suppose you just plotting here, this is the salary and this is the probability of purchase. Okay. Now, say okay. Now suppose if suppose you are earning a 1500 US dollar per month. Suppose you are earning a 1500 US dollar, then you cannot even think to buy a flat in US. Okay, because you see it is condensed to zero. But if somewhere you're getting $2,000 as a salary, then there's a probability of 50-50%. But if you put some effort, then might be you can have your own home. Otherwise, there might not be the chance also. So this 2000 is what? It is the 50-50% probability where you can have your flat in the US. But here if you see that if you get the 1500 US dollar per month, then there is no chance to buy a flat in US. So if there's no chance when you are getting 1500, then can I say that will you go for check that whether if I get 1400 US dollar per month, so I'll be able to buy a flat or not? If it is already clear to you that if you're even getting 1500 US dollar per month, then you cannot buy a flat in US. So if that is applies to 1500, then it will be applicable to all the salary which is less than 1500. Yeah. So whether it is 1400 or 1490, since it is less than 1500, so you cannot have the flat in the US. But again, I'm telling you, if you're getting 2000 US dollar per month, then there's a 50% chance that you can have your own flat in the US. But if you are getting 4000 US dollar per month, then in US surely you can have your own flat. If you're getting 4000 US dollar salary then per month, then surely you can have your own flat in the US, for example. So that means, can I say that whether I'm getting 4000 or whether I'm getting 5000 US dollar per month, that means same for me, because in both the cases I have 100% chance that I can buy my own flat. I can buy my own flat. You see? So for me, the chance will always be zero if I'm getting the salary less than 1500. And in the same way, there will always be chance to have a flat or to buy a flat in US if I'll be getting salary either equals to 4000 or more than 4000, because it is 100%. So you are getting 4000 or 5000, it will not matter. Yeah, means here just because of that, once I have reached to this 4000, once I have reached to this 100%, after that, instead of increasing towards up, my line will become flat. In the same way, increasing of going towards down, my line will become flat. And just because of that, what has happened, my linear curve, my straight line has becomes S curve. My straight line has become sigmoid curve. Okay, everyone. I hope you understand. Next. So this is the way how your linear regression actually convert into logistic regression. And again, I tell you, so right now what is happening, when you'll be getting 1,500 US dollar salary, so it will become 0. And when you're getting 4,000 US dollar salary per month, so its probability will become 1. And the data that you're seeing here, the probability that you're seeing here, it will lie between 0 to 1. Means again the continuous. So what I think that if I take this 0.5 as my reference line, then I can say that if I'll be getting salary less than or equal to $2,000, then there's 0 probability. And if I'll be getting the salary more than 2,000, then I'll be getting the chance to buy the flat. And in this way, either I'll be able to buy, or I'll be not able to buy, or I'll be able to buy. My entire data has been predicted in terms of yes or no. Yeah. So in this way, your logistic regression actually works. Now let me show you. Next. So you see, this is the equation of a straight line. Yeah. This is the equation of a straight line that you are going to use here. Then we have this, where if the E value is 2.7183, and y is what? Y is beta naught plus beta 1 x1 plus beta 2 x2, so on, so forth. So when I'll be putting this value into exponential, yeah, can I say that I'll be getting the continuous value? I'll be getting the continuous value. Okay. So for example, you see here that if I have binary class, if my output is binary, then, and it is having 2 category, then it is called as binary. And if there are more than 2 category, then it is called as nominal. And if I'll be having more than 2 category, but they are unaged, they are in a particular sequence, so that is called as ordinary. Next. So these are the certain assumptions that we used to follow in case of logistic regression. And what is that assumption? First is only one outcome per event, like pass or fail. Yeah, 0 or 1. And whatever outcomes you'll be getting, that will be statistically independent. Means if you are getting 0, so you are getting the 0 not because of the 1. And in the same way, if you are getting 1, so this is not because of the 0. Okay. And just to get the proper classification, what is the requirement? All the relevant features, all the relevant predictors should be taken in the model. Yeah. And the output will always be like that, only one at a time, either yes or no. So these are the several model assumptions that are applied in the logistic regression. Now, suppose when your y is discrete, and your x is single and continuous, so what you're going to apply? You're applying simple logistic regression. And when your y is discrete, but your X is single and categorical. In that case, what you will do? You'll be just creating the dummy data of your X, and you know that creating the dummy data of X means you are doing one-hot encoding. Okay, and once it is done, then what is there? You'll be applying simple logistic regression. So friends, just have a look on this use case where what is happening. Imagine that you're a data scientist at a very large scale integration circuit manufacturing company. You want to know whether or not the time spent inspecting each product impacts the quality assurance department's ability to detect a designing error in the circuit. Means somewhere you just want to see whether the time spent while doing inspection will be able to find out the error or not. Yeah, and for that purpose, we have to build our model. So guys, you see, this is my data. And in this data, you see that we have this error identification, which is my Y. And this inspection time is what? It is my input. Okay, so we have how many rows? We have total 55 rows. Now, when you are applying logistic regression, then suppose this is the value you are getting. Yeah. And if this is the coefficient of determination, then what will be the equation? It will be y equals to minus 9.947 plus 0.329 into x. So guys, if you look at this equation, can I say that this is the equation of the straight line? Isn't? Now you see here, suppose any value you check here. We have lot of x value. Say we put any x value. Suppose the 34. So when you will be putting here 34, so minus 9.947 plus 0.329 into 34. So the value that you are going to get here, will it be continuous or categorical, everyone? Please tell me. Will it be continuous or discrete? So obviously it will be continuous. Yeah. Okay. So just like here, you see this equation we got, and you know that this is the probability equation we have. Now, when we are putting the input value as 40, so when we had put it input value as 40 here, so what is the value of y we are getting? That is 3.20. 3.20663. Okay. Now this is the value of y. And you know already that the value of e is what? 2.7183. So we'll just put this value into this p, and this will become my equation. And when you will solve it, then you'll be getting 0.9611. Yeah, you'll be getting 0.9611. And what will be my summary? So in summary, I will say that if you spend 40 unit of time, to identify the error, then there's a 96.11% chance that you will discover the error. You will discover the error. I hope you understand, everyone. Okay. So in this way, we are doing the things. Now, suppose that we have this inspection time, and according to that, we just got the probabilities for each, according to each inspection time. Say, if we are spending the 38 unit of time, then the probability to discover error is 92.8%. When we are spending 29 unit of time, then there's only a 39.9% of probability to discover the error. So what we did, in the x-axis, we took this as inspection time, and in the y-axis, we took the probabilities, and we plotted the value. You see what we got? We got this S-curve. Now, if I go to the middle of this S-curve, I think somewhere it will be here. Okay, somewhere this is here. And if I take up to this, so I think that will be around 34 minutes. Huh? So what is the meaning of that? This means that if you spend 34 unit of time, if you spend 34 unit of time, then there's a 50% chance that you can find out the error. Yeah. So suppose I just made my 60% probability as the threshold value. I just made 60% probability as my threshold value. And now if I work on it, then I can say that if somebody spend less than or equals to 35 unit of time, then he or she will not discover the error. But yes, if the amount of time spent is more than 35 unit of time, then there will always be chance to do to identify the errors. Okay, is that clear, everyone? Any question? Okay, so you know that when you're working on the regression, then your goodness of it was R squared, and the accuracy that you are examining, the correctness of the model you are examining, in terms of what? In terms of the root mean squared error. Okay, now in case of classification model, the accuracy is determined on the basis of the accuracy underscore score. Okay, and the reliability of the model is judged on the basis of the average F1 score. So we'll see it. We'll see it what exactly these are. But yes, for your kind information, I'm telling you that in case of classification, the evaluation metrics get changed, while in case of regression, it was R square, and in case of classification, it is accuracy underscore score. And this accuracy underscore score is what it is depend upon the confusion matrix. Yeah, it depends upon the confusion matrix. Okay, now I'll just cover this. Let me give some time. Let's talk about this confusion matrix. So, you know, we will have this Y. What did this Y call us, everyone? Actual output. And what is this Y cap? It is the predicted output. Suppose the actual value is positive. The actual outcome is positive. And the predicted outcome is what? It is also positive. Say that the actual value of Y is negative. Actual value of y is negative, and the predicted value is positive. Then actual value is positive and the predicted value is negative. Another is actual value is negative and the predicted value is also negative. Okay. Now what we will do in case of result, we'll just write the value of the predicted value. So what is the value? What is the predicted value we have? Can I say it? P, P, N, and N? Isn't? So what we did, we just directly kept the value of predicted output. Now, wherever there is a match, so actual your predicted value is P and your actual value is also P. So there's a match, everyone. So there's a match means it is true. Actual value is predicted value is positive and the actual value is negative. So there's no match means it is false. Actual predicted value is negative and actual value is positive. So there's match, obviously not. So it is the false negative. And here, although the predicted value is no and the actual value is no, so there's a match. There's a match. So whenever there's a match, there's a true. There's a true, and so that means it is your true negative. So first of all, I hope you understand how this true positive, false positive, false negative, and true negative we discovered. Let's define them. So can anyone tell me on the basis of this, what is the true positive?
When the predicted output and normal output is both predicted, means positive.
Yeah, it means when your model has predicted positive and your actual y is also positive. So it is what? It is true positive. In the same way, what is false positive? So again, you see here, what is the meaning of false positive? Actually, the output was negative. Actually, the output was negative, but the model has done it as positive. So it's a false positive. Okay. Now, let's talk about this false negative. So what is the false negative definition here? You see, the actual value of y is what? Positive, but the model has predicted it as negative. So what is the meaning of that? False negative. And what is this true negative? So true negative is where actually the output was negative and your model has also predicted it as negative. Now guys, let's take the example of the COVID cases. Suppose one person has gone for the COVID test and he or she got this result. So when we are talking about this, how can you define this true positive now? So you can say that actually the person was suffering from COVID positive and your model has also predicted him as COVID positive. Now, the next thing is that actually the person was not COVID positive, but your model has predicted him as COVID positive. So it is what? It is false positive. And the next one is what? Again, see, actually the the person was suffering from COVID, the person is COVID positive, but your model has find him COVID negative, find him healthy. So it is what? It is false negative. And when both are N, so it's a true negative. Okay. So if I ask you everyone that out of this, what do you think? Which one is more dangerous? False positive or false negative?
False negative.
False negative.
False negative. Why false negative? Because, suppose the false positive case is there. So in the false positive case, what is there exactly? The person is not suffering from COVID. And suppose the model found him as COVID positive. So what it will do, we'll just put that person for the quarantine and we'll be giving him the healthy diets. So somewhere his health will improve. Although that was misclassification, but still there's no any harm. Why? Suppose the person was COVID positive and your model just find him COVID negative. So what will happen? You will become super spreader of the COVID. And this is why when you look at this confusion matrix, you had this true positive, false negative, and true positive. I hope now you understand it. Okay. So if I ask you, this is my result, then what is the accuracy?
50%.
No. How will be calculating the accuracy? So the accuracy will be what? The total correct prediction upon number of the data points. So you see here, if I look at this table, then where you are seeing the correct prediction? Everyone? So the correct prediction will be either in case of true positive and in the case of true negative, where the prediction and the actual values are matching. So if I'll have to find out the accuracy, then how can I do that? It will be true positive plus true negative upon total. Yeah. So in this way, we can find out the accuracy underscore score. So what accuracy underscore score I was talking about, this is actually the value you'll be getting after applying this formula. Okay. Now, I tell you, whenever you will have classification model, then the correctness of the model, then the reliability of the model is determined on the basis of the F1 score. It is determined on the basis of the average F1 score. So what is this average F1 score? I tell you, this average F1 score is actually the harmonic mean of the precision and recall. And when you will solve it, so it will become 2 precision into recall upon precision plus recall. Okay. So that means, hold on. Which one?
This part, this average.
Okay. Yeah, I'm telling you. So basically, whenever you have to do classification and you have to check the correctness of the model, then the best reliable term is what? Average F1 score. And how this average F1 score is calculated, it is on the basis of the harmonic mean of the precision and recall. And how this harmonic mean is determined? So it is determined 2 upon 1 upon P plus 1 upon R. So what is P here? So the P is precision. And what is the R? R is the recall. So before applying this formula, we must be knowing about the precision and recall. Okay? Precision and recall. So let's talk about this precision. Precision says that out of total positive prediction, out of total positive prediction. So where your model has predicted positive, so can I say this one and this one? This is the positive prediction and this is the positive prediction. So corresponding to this P, what we have? We have TP. Corresponding to this P, what we have? We have FP. So please mind my words. If you want to define the precision, then what is the precision? It is the out of total positive prediction. So you got, please mute. So that is TP plus FP. So out of total positive prediction, how many positive predictions are done correctly? So out of this TP and FP, which is the correct positive prediction, everyone?
TP.
TP?
TP.
So that is TP. So this is the formula that you got, true positive upon true positive plus false positive. And what is that? It is precision. That is out of total positive prediction, how many are positive prediction done correctly? Okay. Now, let's talk about the recall. How the recall is done? It says that out of total actual positive cases, out of total actual positive. So let's move into this actual. In this actual, where you are finding positive, everyone? So in this actual, you're finding the positive at this first and at this one. And corresponding to this P, what is there? It is TP. And according to this P, what is there? It is FM. Yeah. So I can say that out of total actual positive cases, how many positive predictions were done correctly?
1.
So that is true positive. This is the positive prediction that was done correctly. So how the recall is calculated? True positive upon true positive plus false negative. I hope that is clear to you all, everyone.
Yes, sir.
Yes,
Yeah.
sir.
So in this
Can you
way,
label P and R?
yeah, please.
Can you label P and R?
Yeah, P is what? Precision. And R is what? Recall. Now, if I want to increase, if I want to increase my accuracy, can I say that in that case, I'll have to increase my precision and recall both? And
Yes, sir.
if I want to increase my precision, then obviously somewhere I'll have to decrease this false positive case.
Yes, sir.
And if I want to increase my recall, then somewhere I'll have to decrease this false negative. Okay.
Yes.
So in this way, you just try to calculate the average F1 score, which is the harmonic mean of the precision and recall. And I tell you one thing, this recall is also called as sensitivity. This recall is also called as sensitivity. So you now got this definition of all of the things and how you can calculate the error. Just reverse of the accuracy means wherever you got the false upon total. Then we have this precision and recall. So we had discussed about the precision. We had discussed about the recall. Let's talk about the true negative rate, that is the specificity. So specificity says that out of total actual negative cases. So guys, where you are finding out the total actual negative cases? So actual negatives are this and this.
Second and last.
Yeah, that means false positive plus Tn. So that is true negative plus false positive. Can I say that? So I can define this specificity as out of total actual negative cases, how many times the model has done negative prediction correctly. So you know that the negative prediction correctly is what? True negative. So this Tn upon Tn plus Fp will become what? It will become specificity, true negative rate. Okay. Just give me 1 second. Yeah. So you see, whatever things are written here, now we know that. And if you have to calculate this false positive rate, then how can I do that? The false positive rate or the alpha or the type 1 error is 1 minus specificity. And what is the type 2 error? It is the 1 minus sensitivity. Okay. F1 score we have come to know. And you see, when this F1 score will always try to get this F1 score near to 1. Yeah. This is the last concept, that is the ROC curve. This ROC curve is basically tell about the correct, how exactly or how much your model is correct. Yeah. It is basically talk about the reliability of your model. For example, you see here, ideally your model should be like the this, 1 second. Why I don't know, this PPT is creating some problem. Okay. So you see here that ideally your ROC curve will be just like this one. Okay. Where there's a 100%. When you will be building your ROC curve, then actually this will be this one, this blue line, which is the actual one. And here we'll be finding out where we are getting the bend. So you see, I think the bend you're getting at this point, isn't? So when this is your bend, so that means what? The value here, it is showing somewhere. Guys, please help me out. I think it will be somewhere 76 or 77%. Can I say it? According to this bend, when I match with the y-axis, then it is somewhere 77%. So The 77% can be represented as 0.77. Now, if the area under curve by this ROC curve is between 0.5 to zero point 0.6, it means your model will not be able to do discrimination, to do classification. And if the values in between 0.6 to 0.7, it means your model is poor. So in this way, on the basis of the bend that you are getting, on the basis of the value that you are getting, you can talk about the reliability of the model, that how much your model is reliable. So this is all about the logistic regression. And I tell you here that this ROC curve, this confusion matrix, F1 score, they are not only for the logistic regression, they are the evaluation parameters, they are the evaluation metrics for all classification algorithms. They are for all classification algorithms. So before starting implementation, guys, if you have any question, then you can ask me. Feel free to ask me. Okay.
Sir, can you explain the ROC curve once again?
See, when we talk about this ROC curve, so ROC curve is not telling you about the accuracy, I tell you. ROC curve is somewhere trying to tell you that how much you can rely on your model. Yeah. And ideally, obviously, it will be 100%. But in actual, how you'll be determined that how much reliable this model is. So it will be depending upon when you will be creating the ROC curve. Then on the ROC curve, you are going to get in this way. You're going to, even not in this way, you're going to get in this way. There will be a bend in this way. So wherever you'll be getting this bend, and when you'll match with the y-axis, whatever percentage you're getting, it will be actually telling you the reliability of your model. So you see, if the value you're getting between the 0.7 to 0.8, that means your model is acceptable or fair. You can rely on it. But if the value you'll be getting between 0.8 to 0.9, that means your model is excellent. Okay.
Okay, sir. Thanks.
Yeah. Now, suppose we are just working with this data. So we are importing this pandas, we are importing NumPy, matplotlib. Then we are reading this data. And what is this data we have? It is the user underscore ID. And you see, here we have 5 columns: user ID, gender, age, estimated salary, and the purchased. Now, guys, if I ask you, do you think that this user ID will have any statistical significance? Everyone?
No, sir.
No. So what we will do, we'll just remove it. Okay. Now, my another question. Do you think that this gender column will have any statistical significance to determine this purchased? I think it is yes. For example, suppose the item is cosmetic product. So obviously, you know that if the gender will be female, then there will always be more chance to get purchased this. Yeah. So yes, might be there will be some statistical significance of the gender over your output variable. And again, guys, it is your call. It is your domain knowledge. You just need to understand it. Second thing is, one second. Second thing is that even if you're not able to determine that whether this particular column is having any statistical importance while determining your output or not. So one thing is that you can decide on the basis of your domain knowledge or your experience, or you can do another thing that is called feature importance, if you remember. Yeah. So on the basis of the feature importance, also you can come to know that whether this gender column is important or not. Okay. Now somebody was asking any question.
Sir, in that gender, so you have to do like one hot encoding, then you have to like estimate a value about it, right?
Perfect there. Perfect. So since your gender is the input variable, so you'll be applying one hot encoding. Yeah. So if I look at this purchase, how many unique values are there? That is 0 and 1. Now, you see why I'm applying this get underscore dummies? Just to do one hot encoding on my data. And this get underscore dummies will do what? It will just convert your text data into discrete one. Okay. Now, you see, so you have done your gender into female and male, isn't, by doing the one hot encoding. Now, what we will do, we'll just segregate our data into X and Y. So can I say that in this X, what will be the different value we'll have? What is the different columns we'll have? So in the X, we will have age, estimated salary, gender column. And in the Y, what will happen? We will have purchase only. Okay. So that's why you're seeing that in this X, we are keeping the 1, 2, 4, and 5th index. So in the X, we have kept this one, and in the Y, we are keeping the value at the 3rd index. Next. If you see the shape of your data, and what is the shape we have? It is 400,6. Okay. It is 400,6. Now, what we will do, we'll just split this data into what? Into train and test. And see, what is the test size we have? It is 0.25. So 75% we have split it into train, and the 25% we have split it into test. Now, guys, when you look at the column mean value, you see there's a huge difference between the age and the estimated salary. Means my data is suffering from a scaling issue. So what I'll do in that case, I'll just do either normalization or standardization. So I'm just I'm just doing a standardization on my data, on my train data and test data both. Okay. So far, any question, everyone? Then after, you see, so after that, we are building the logistic regression model. So this is the logistic regression. We are importing from where? Guys, if you see here, we're importing this from sklearn.linear underscore model. Even here also you can see that somewhere your model is considering this logistic regression as the linear model. Okay, so we are building this model and we are initializing this model into which variable? Into this classifier variable. And then we are training this classifier model on the trained data through fit function. Okay. Now let me do prediction on the test data. So this is my model. We are calling the predict function on my test data. You see, so the first list that we are seeing from here to here, it is what? It is the predicted value of y, and this is what? This is the actual value of y. Let me show you in this in the data frame. So yes, you see, maximum time there is a match. Maximum time your actual value is matching with the predicted value. So what we will do now, we'll just create the confusion matrix. So when we'll be creating the confusion matrix, what we are going to get, everyone? Whenever we'll be creating the confusion matrix, what things we are going to get? The true positive, false positive and all?
The P and R.
Yeah. So no, not P and R. We'll be getting true positive and false positive, true negative and false negative. Although by showing them, by using them, we can derive the P and R, but using the confusion matrix, we are not going to get that. So you see, from sklearn.matrix, we are importing this confusion matrix, and then we are applying this confusion matrix on what? On my actual data, actual output, and my predicted output. So when I ran this, you see, what is the value you got? This one? Yeah. So this 64 is what? It is true positive. This 27 is what? True negative. So how you'll be calculating the accuracy part? So it is 64 plus 27 upon total. So how much accuracy we got? We got 91%. The 91% accuracy we got. Let me calculate the accuracy score. So I told you that this is actually your accuracy underscore score. And if you want to get it directly, then you can import this accuracy underscore score from sklearn.matrix. And when you will be applying it on my y test and y pred, then you see it is giving me the 91% accuracy. Now, let me show you classification report. So this classification report, if I have to find out, and guys, to be very frank, this classification report is going to give me the precedent and recall. So from that sklearn.matrix, I have imported this classification underscore report, and we are applying this classification underscore report on what? On my test and prediction data. You see? So this is the precision, recall, F1 score, and support. All right. Now you see here, what is the average F1 score? Why I'm telling you the average F1 score or this accuracy? Because you see that it has calculated the precision recall F1 score class wise. Yeah. So when you will take the 93 plus 86 upon 2, what is the value you'll be getting, everyone? 93 plus 86 upon 2.
Or 90.
91. Yeah. Okay. Next, you see here, what was the shape of the test data? We were taking 100 rows, no? We were taking 100 rows. So what is the support? Support means out of this 100, you took 68 0 and 32 1. Out of this 100, what you did, you took 68 0 and 32 1. Okay. So this is the precision of the 0. This is the recall of the 0. This is the F1 score of the 0. This is the precision of the 1. This is the recall of the 1. And this is the F1 score of the 1. Now, what is this macro average and the weighted average? Okay. So you just simply find out the average of it. That is your macro average. You will just take the simple average of these, then it will become the macro average. And what this weighted average says that why to take macro average? If the proportion of 0 is more, then why it will be treated equally? If the proportion of 1 is less, then why it will be treated equally? So you know that total how many data you had? 100. Out of that, you took 68 0. So what is the proportion of 0? Can I say it is 0.68? And in the same way, out of total 100, how many 1 is there? 32. So what is the into 68.68 plus 0.87 into 0.32. Please tell me the answer, everyone. So 0.93 into 0.68 plus 0.87 into 0.32. So what is the answer you are getting? 0.9108. Can I say that this is the weighted average? Even if you want to see, again, let's see here. Let's talk about this recall. So 0.94 into 0.68 plus 0.84 into 0.32. What is the value you are getting? 90.799. It is somewhere 91. So guys, in this way, the weighted averaging technique is calculated. And I tell you, for our analysis purpose, for our inferences purpose, we always prefer macro average instead of this weighted average. Yeah. So this is the classification report of the test data. Any question? Okay. So now we'll be doing prediction on the trained data. The way we have done prediction on the test data, in the same way, we are doing prediction on the trained data. And you know, so in the same way, we'll be finding out the confusion matrix, and this is the train accuracy. So if I have to find out the accuracy, then how can I do that? 172, which is true positive, 78, which is your true negative. So 172 plus 78 upon total. What is the accuracy you are getting? 83. Yeah. And even if I go with the classification report, it is 83. Next thing is that if you see the accuracy underscore score, so it is 84. It is 84. Now your train accuracy is 84, your test accuracy is 91. Although I tell you, in most of the cases, you'll be getting test accuracy lower than the train accuracy, but exception can also be arises. And whenever you just get the test accuracy higher than the train accuracy, do one thing, change the proportion of train test split. Yeah, increase the proportion of train data in comparison to test data. Yeah. Like here, you see, we have splitted our data into 75-25, isn't? Yeah. So you can do what? You just try with the, you just increase the proportion of trained data from 75 to 80, and let's see what happens then. Okay. So let me draw the ROC curve of the test data. Okay. So here we just call this ROC curve, and we got what? False positive rate and the true positive rate. So we'll be just plotting this false positive rate and true positive rate. So you see, this is my ROC curve. And according to this ROC curve, where we are getting bent, everyone? It is somewhere 0.83.
Yes, sir.
Yeah. So according to this, if I refer my ROC curve, then it is more than 0.8. That means my model is excellent. That means my model is excellent. And the way I have created the ROC curve for the test data, in the same way, you can create the ROC curve for the trained data. So this is all about the today's session. And if you have any question, then you can ask. Yeah, everyone, any question? Okay.
Sir, I have a doubt, sir.
Yeah, please.
Sir, you have mentioned about micro-weighted, like where will it be used?
No. Macro average mostly we use. Weighted average we can use. Yeah, we
Like
can
it's
use.
like both are similar, like means
Yeah, yeah.
almost same. So would it be like we'll make a bias upon macro average, it's like that?
Actually, I tell you, whenever we work in the real environment, working on any algorithm and whatever machine learning approach you use, it is always experimental. So basically, we will not only be using macro average, we'll be using the weighted average also. And whichever will be giving us the best accuracy, we'll follow them. Yeah. The
Yes.
entire machine learning is the name of seeing the multiple options, and whichever option is giving you the best result, follow them. Okay, dear?
Yes, sir.
Yeah. So let's stop here, everyone, and let's meet tomorrow. Till then, thank you, everyone. And as I told you, once I would have completed your machine learning algorithms, then I'll get back to the AI concepts. And probably, again, I'm telling you, from Tuesday, we would have, or the Monday, we would have splitted your batch into AI and ML.
Sir, where do you have to submit the assignments?
I will share the link. Actually, I didn't get the time to create the link, but just today I'll be creating link and you'll be submitting over there.
सर नोट्स भेज दीजिएगा सर नोट्स भेज दीजिएगा
मैं अभी भेजूंगा अभी टाइम तो दीजिए अभी ये कंप्लीट कर दिया मैं आपको पीपीटी वगैरह सब भेज दे रहा हूँ ठीक है और दूसरी चीज सेकंड थिंग गाइस ट्राई टू अंडरस्टैंड you will have to explore yourself also, but I'll share all the materials that I have used. Okay, everyone?
Excuse me, sir.
Yes, Somna.
Sir, all the concepts that we have done in the past 10 days, sir, like what can we do? Like I have seen that during doing the assignments, not everything was being used. So like how can I be able to keep myself up to date with all the concept that you have taught?
Okay, Somnath, I can do one thing. If you just go and check whether I have shared one dirty data that is Titanic. That Titanic data is really very perfect data just to work with all kind of cleansing process. Otherwise, Somnath, if you'll be trying to apply all the concept on a single data, that will never be possible. Because all data will not have same kind of problem. first thing. Second thing is that might be there will be some data which has lot of columns, but they don't have missing value. So that's why what I'll do, I'll just share you the Titanic data, and maximum things that you would have done, you can do over there. Okay, now I'll be sharing today the assignment of the multiple logistic regression, and you will find out there the data on which you can apply the logistic regression. And Somnath, I tell you, only the project is that part where the maximum thing you can apply. Again, I'm telling you maximum thing. I'm not telling that 100% things you can apply over there. Okay?
Yes, sir.
Yeah.